time frozen. Galaxies hang in silence, as if caught in mid-turn, their spiraling arms suspended like brushstrokes on an unfinished canvas. Stars, burning for billions of years, seem paused in their fiery breath, flames held still in the vacuum of eternity. The universe in this vision is not a story unfolding, but a sculpture, unmoving, eternal. And yet, within this stillness, a paradox lingers. Infinity, a word that suggests no beginning, no ending, ocean without shore. But how can something infinite ever start? If infinity stretches forever backward, then there was never absence, never emptiness, never a moment when nothing truly existed. Still, the evidence whispers otherwise. Astronomers trace the fading glow of the cosmic microwave background, the afterlight of an ancient ignition. They speak of a time when the universe was compressed into something unimaginably small, dense beyond measure, and then, in a single instant, expanding outward into everything we see today. But if infinity means there was never nothing, then why was a beginning required at all? Why did the silence rupture, the void ignite, the timeless suddenly give way to time itself? This question is not only about galaxies or physics, it is about existence itself. Why is there something rather than nothing? Why does the cosmos breathe with stars and gravity rather than resting forever in quiet emptiness? In that mystery lies the greatest riddle science has ever dared to touch, an enigma, not only of cosmology, but of being. Chapter 1: The First Breath of Infinity. At the dawn of the 20th century, the universe seemed eternal and unchanging. Astronomers looked upon the heavens and assumed what had always been true would remain true forever. Stars fixed in their constellations, galaxies, though not yet understood as such, quietly circling in stillness, like lanterns suspended in the night. To imagine otherwise felt almost unthinkable. But mathematics had other plans. In 1915, Albert Einstein unveiled his general theory of relativity. With it, space and time were no longer separate backdrops for the cosmic play, but threads of the same fabric, woven tightly together and bent by mass, by gravity, by the invisible weight of existence itself. It was not a static canvas, but a living geometry. The equations he wrote did not simply describe matter in space, they described space itself as a participant in the story. Yet when Einstein followed the mathematics where it led, he encountered something deeply unsettling. His equations suggested that the universe could not stand still. Space must either expand or contract. The cosmos itself must be in motion. For Einstein, this conclusion felt absurd, almost dangerous. He believed, like nearly all of his contemporaries, in a timeless, eternal universe. And so, to rescue the heavens from this unwanted restlessness, he inserted into his equations a balancing force, a term he called the cosmological constant. It was a kind of mathematical glue, a steady pressure pushing outward, designed to hold the universe in place. Later, he would call it the greatest blunder of his life. For a few years, the illusion of stability remained intact. Observers with their telescopes saw little reason to imagine otherwise. The Milky Way, they thought, was the whole of creation. Beyond its stars, perhaps only a haze of mysterious nebulae. The night sky appeared, as it always had, vast, tranquil, eternal. But in the mountains of California, Another truth was quietly being prepared. At the newly built Mount Wilson Observatory, astronomer Edwin Hubble peered deeper than anyone before, using the 100-inch Hooker telescope, the largest on Earth. At the time, he studied faint smudges of light scattered across the heavens. These spiral nebulae were long-debated curiosities. Some insisted they were mere clouds of gas within the Milky Way. Others dared to propose they were entire galaxies, vast island universes of stars, millions of light-years away. Through painstaking measurement, Hubble resolved individual stars within these distant swirls. Among them were Cepheid variable stars, whose rhythmic brightening and dimming acted as cosmic lighthouses. Henrietta Leavitt, years earlier, had discovered that the period of their flicker revealed their true brightness. Compare that to how bright they appear from Earth, and their distance could be calculated. Hubble used this stellar yardstick and proved beyond doubt that these nebulae lay far outside the Milky Way. They were galaxies in their own right, separated from us by unthinkable gulfs of space. The universe was not a single city of stars. It was an archipelago of countless cosmic continents. And then came the deeper revelation. Hubble examined the light of these galaxies and noticed a strange, consistent pattern: the absorption lines. In their spectra, the fingerprints of elements within their stars were shifted toward the red end of the spectrum. This was not random. The farther a galaxy lay from Earth, the more its light was stretched, reddened, as though carried away by an invisible tide. In 1929, Hubble published his results. Galaxies were not static. They were racing away from one another. And not only that, the velocity of their flight was proportional to their distance. The farther away a galaxy was, the faster it fled. This was not the motion of objects drifting through space. It was space itself expanding. The universe was not eternal, not unchanging. It was alive, growing, swelling outward with every moment. And if it was expanding today, logic demanded it must have been smaller yesterday, smaller still the day before, until, unimaginably, it must once have been compressed into something very near to nothing. Here, the paradox sharpened into focus. If the universe had a beginning, what came before? If all space and time erupted from an initial point, what ignited that eruption? And if infinity means there was never an absence, how could there have been a moment when everything was absent, waiting for creation to begin? Scientists, philosophers, theologians felt the tremor of this discovery. A beginning implied more than physics. It suggested metaphysics. It suggested an origin of not only matter, but of time itself. A line of causality could not be drawn before that moment, because there was no before to place it upon. The birth of the universe was the birth of time's arrow. In this tension lay the first breath of infinity. Einstein reluctantly conceded to the evidence. His equations, freed of the cosmological constant, matched Hubble's findings with uncanny precision. What he had once resisted now seemed unavoidable. The universe was dynamic. It had a history, and, like all histories, it carried the whisper of a beginning. Others followed this trail into even deeper speculation. The Belgian priest and physicist Georges Lemaître proposed what he called the primeval atom, a moment when all energy and matter were contained in a single, compact seed before exploding outward to form the cosmos. Later generations would call it the Big Bang. Yet, as profound as this picture was, it carried within it a haunting question. A universe with a beginning suggests a universe that could have been otherwise, a universe that might not have been at all. Why did the fabric of existence unfurl instead of lying dormant in eternal stillness? Infinity complicates the riddle. To say that time began is to say there was once no time, but infinity whispers that there was never a once without it. If infinity stretches endlessly, then absence itself becomes impossible. There is always something, always continuity, and yet, in the observable record, we see an unmistakable beginning. 13.8 billion years ago, light itself burst into being. Chapter 2: The Shock of the Big Bang. The first breath of the expanding universe carried more than light. It carried a shockwave through human thought itself. For the cosmos was no longer eternal, no longer steady and unchanging. It had a history, and, like all histories, it hinted at a beginning. In the 1920s, one man dared to trace this revelation to its origin. Georges Lemaître Priest, mathematician. Physicists stood at the crossroads of science and faith, yet spoke with the restraint of equations rather than sermons. Where others saw only an expanding universe, Lemaître imagined the moment before the expansion began. He described it not in mythic terms, but in the language of physics. The universe once compressed into what he called a primeval atom, a cosmic egg containing the totality of space and time, shattering in a silent eruption to form the galaxies, the stars, the very fabric of existence. From this singular point of unimaginable density and heat, all else would flow. The universe was not infinite in age, but finite, with a birth, a moment zero. This idea was radical and settling. Even for centuries, philosophers and scientists alike had been guided by a vision of eternity. Aristotle's cosmos was eternal, without beginning or end. Newton's universe stretched infinitely in both space and time, a stage upon which celestial mechanics played forever. Even Einstein, when faced with his equations suggesting expansion, had preferred the stillness of a balanced, eternal universe. To suggest otherwise was to break from tradition, to disturb the comfort of infinity. And yet, Lemaître's vision was grounded not in speculation alone, but in mathematics and the evidence gathering quietly in telescopes. The expansion revealed by Edwin Hubble implied a past contraction. Rewind the universe far enough, and all galaxies converge to a single point, not a point in space, but a point where space itself begins. The shock of this idea reverberated deeply. If the universe had a beginning, then time itself had a boundary. And if time had a boundary, then infinity, the endless past, was an illusion. For infinity, by its nature, cannot be bounded. Yet, here was a boundary, sharp and undeniable, the origin of all things. 13.8 billion years ago. Not all were prepared to accept it. In the 1940s, a competing vision rose to prominence, crafted by Hermann Bondi, Thomas Gold, and Fred Hoyle. This was the steady-state theory. Its elegance lay in its refusal to concede to a beginning. According to this model, the universe was indeed expanding, as Hubble had shown, but it did so eternally. As galaxies drifted apart, new matter spontaneously appeared to fill the void, keeping the density of the cosmos unchanged. The The universe had no birth and no death, only eternal renewal. It was a cosmos without edges, without moment zero. Fred Hoyle, with his sharp wit and gift for language, delivered the most memorable blow against Lemaitre's proposal. In a BBC broadcast in 1949, he dismissed it with a mocking phrase, "the Big Bang." He intended it as ridicule, cosmic, explosion too simplistic, too theatrical, too much like creation myth disguised as physics. But the name stuck. What began as derision became the label for one of the most profound ideas in science. To many, the Big Bang seemed outrageous. How could all of space and time erupt from nothing? How could existence itself have a starting point? The steady-state model offered comfort, preserving infinity, continuity, and the philosophical symmetry of a universe without origin. It promised permanence, a cosmos that needed no cause, no first moment, no unsettling birth. But the data refused to yield. In the early 1960s, radio astronomers Arno Penzias and Robert Wilson stumbled upon a faint, persistent hiss of microwaves. It seemed to come from every direction, day and night, with no source that could be tuned away. They tried everything, checking their equipment, even cleaning pigeon droppings from the antenna. Still, the hiss remained. What they had found was the cosmic microwave background, the afterglow of the Big Bang itself, stretched and cooled by billions of years of expansion. This faint radiation was the fossil light of the universe's first fire, still bathing the cosmos in an invisible sea of photons. It was the death knell for the steady-state model. For no eternal, unchanging universe could produce such a glow. Only a universe with a beginning, a searing birth, could leave behind such an afterimage. And so the shock deepened. The Big Bang was no longer just a theory. It was written in the sky, etched into the microwave whisper of space itself. The implications were staggering. The universe had not always existed. It came into being in a moment of unfathomable density and heat, expanding and cooling into the cosmos we inhabit. Time had a beginning. Infinity, as human imagination conceived it, was interrupted. But this birth carried with it a riddle. For if the universe emerged from a singularity state where density and temperature reach infinities of their own, then the laws of physics collapse. Relativity cannot describe it. Quantum theory falters. To ask what came before is to step into a place where before has no meaning, for time itself did not exist. This was the true shock of the Big Bang. Not only that the universe had a beginning, but that human reason might never penetrate what lay beyond it. To some, it seemed uncomfortably close to creation. A cosmos with a birth sounded like a cosmos with a cause, an echo of theological language woven into physics. Scientists like Hoyle resisted it for precisely this reason, fearing that science would be blurred with metaphysics. Lemaitre himself, though a Catholic priest, insisted on keeping the two realms separate. The primeval atom was not a doctrine, but an equation. Science, he said, describes how the universe unfolds, not why it exists. Yet the clash persisted. Eternal universe. Chapter 3 Echoes of Creation. The universe, it seemed, had spoken, but its voice was faint, almost inaudible, a whisper stretched across time, softened by billions of years of distance. And yet, in 1965, two men stumbled upon this echo. Without knowing, they were listening to the oldest song the cosmos had ever sung. At Bell Telephone Laboratories in New Jersey, Arno Penzias and Robert Wilson were testing a large radio antenna, designed not for cosmology, but for satellite communications. They aimed to measure faint signals from Earth's upper atmosphere, refining an instrument that, in principle, had little to do with the origin of everything. But something unexpected interfered. A persistent noise, a soft hiss of microwave static, haunted their receiver. It came from every direction, every season, every time of day. They recalibrated. They checked their electronics. They cleaned nesting pigeons from the antenna and scraped away the droppings, suspecting contamination. Still, the noise remained. What they were hearing was not local, not earthly. It was cosmic, a remnant not of technology, but of creation itself, unbeknownst to them. Just across town, physicists Robert Dicke, Jim Peebles, and David Wilkinson at Princeton were preparing to search for precisely such a signal, a glow predicted as the afterlight of the Big Bang. When the two groups learned of each other's work, the pieces fell into place. The hiss of microwaves was the cosmic microwave background radiation, the cooled remnant of a once blinding fireball. At the dawn of time, when the universe was just 380,000 years old, matter and radiation were still bound in a hot, opaque plasma. Light could not travel freely. It scattered endlessly among electrons and protons. But as the cosmos expanded and cooled, atoms formed, and the fog lifted. For the first time, photons streamed unhindered across space. That light never stopped traveling. It fills the universe still, stretched by expansion into faint microwaves, a bath of radiation only a few degrees above absolute zero. This discovery was a revelation. It was not only proof of the Big Bang, it was the first visible memory of the universe itself. The cosmos was no longer a silent enigma. It carried a relic of its birth, written across the sky. But the whisper was not uniform. It was not entirely smooth. With greater precision came subtler truths. In the 1990s, NASA launched the Cosmic Background Explorer, or CBE. Its mission was simple, yet profound: to map the faint glow of the microwave background with accuracy no ground-based telescope could achieve. When its first results were unveiled in 1992, they showed not just the uniform heat of the early universe, but delicate ripples, tiny variations in temperature, no greater than 1 part in 100,000. Stephen Hawking, upon seeing the data, called it the discovery of the century, if not of all time. For within those ripples lay the seeds of everything. The universe, at its birth, had been astonishingly smooth, almost perfect, but not entirely. Quantum fluctuations, microscopic jitters, born from uncertainty itself, had been stretched by cosmic inflation, magnified into faint irregularities in density. Over billions of years, these subtle imbalances would grow, pulled together by gravity, until they became the galaxies, stars, and planets we know today. The CBE map was a portrait of the infant cosmos, carrying within it the faint fingerprints of quantum mechanics, etched upon the sky. Infinity had revealed its birthmark. A decade later, the Wilkinson Microwave Anisotropy Probe, WAP, refined the image further. Launched in 2001, it painted the early universe in sharper strokes, measuring not just the size of the fluctuations, but their spectrum, their geometry, their underlying laws. From WMAP's data came astonishing precision, the age of the universe fixed at 13.7 billion years, the composition of matter and energy revealed in ratios never before known. And then, in 2009, Europe's Planck satellite took the vision to its pinnacle. With exquisite sensitivity, Planck mapped the microwave sky in the finest detail yet, down to microkelvin variations. What emerged was a cosmic tapestry, patterns of hot and cold, dense and rarefied, each a frozen echo of quantum foam inflated into structure. The implications were profound. The universe was not random chaos, but ordered chaos. Not featureless infinity, but infinity with design. Its birth was written with precision, governed by rules embedded at the smallest scales of reality. Here, in the cosmic background, one sees both simplicity and mystery. Simplicity, because the young universe was nearly uniform, a smooth seed of matter and light. Mystery, because that near uniformity carried within it the seeds of all complexity. Without those tiny ripples, no stars would form, no galaxies would cluster, no planets would orbit, no observers would arise to wonder at the sky. Infinity, it seemed, had structure. It was not an ocean without currents, but an ocean where every ripple mattered. The faint noise discovered by chance in a New Jersey antenna was the whisper of that structure. The breath of creation stretched across eternity. But there was something else, hidden in the data. The background was nearly perfect, yet not entirely symmetrical. On the largest scales, Planck revealed strange anomalies, an alignment of fluctuations, a hemispherical asymmetry, a faint, cold spot, larger than theory predicted. Whether these are statistical flukes or hints of deeper physics remains uncertain. Perhaps they are the scars of cosmic inflation, or echoes of a multiverse brushing against our own. Perhaps they are the fingerprints of physics, not yet written. Whatever their cause, they remind us that even in its perfection, the universe carries mystery. Its first light is both answer and riddle, clarity and enigma. For cosmologists, the cosmic microwave background is a window into a time when the universe was young, smooth, and newly transparent. But for philosophers, it is something more, evidence that existence itself is patterned, that infinity is not blank but inscribed, that the universe remembers its birth. And so the echo continues, carrying across billions of years, every second, every square centimeter of space, bathed in photons born in the first moments of time. They pass through our bodies, our instruments, our world, unnoticed by the senses but not by the mind. To listen to them is to listen to the oldest story ever told, a story not spoken in words, but in light stretched thin across eternity. The universe is not just expanding, it is remembering. And within that memory lies the paradox that began it all: infinity with a boundary, structure born of chaos, order drawn from quantum uncertainty, a cosmos that should not have needed a beginning, and yet carries the imprint of one written into its very light. The echoes of creation remind us that existence is not only vast, but fragile, balanced on fluctuations so slight they could have vanished into nothingness. Instead, they grew, and from them came galaxies, suns, and minds capable of reflection. Infinity, it seems, is not featureless. It has scars, patterns, and fingerprints. It has a story. And that story, still unfolding, is the mystery of why there is something rather than nothing. Chapter 4: The Horizon of Paradox. The afterglow of creation, the cosmic microwave background, seemed to confirm the boldest dream of Lemaitre's vision. The universe was born. It expanded, and it carried with it the faint echo of its fiery childhood. Yet as the details sharpened, what was once a triumph began to reveal a riddle. The universe did not simply exist, it appeared to be too perfect. The first enigma is known as the horizon problem. In the early maps of the microwave sky, regions separated by vast gulfs of space so distant that even light, racing since the first moments of time, could never have bridged them, were shown to be nearly identical in temperature. It was as though two faraway deserts, never touched by the same wind, shared exactly the same climate. How could corners of the cosmos that had never communicated whisper the same thermal story? Then came the flatness problem. The universe revealed itself to be balanced with exquisite precision, its geometry hovering so close to flat that the difference from perfection was less than 1 part in 10,000. In such a delicate state, the cosmos could have easily collapsed upon itself, or expanded so violently that galaxies could never form. Instead, it walked a razor's edge, balanced as though tuned by an unseen hand. The third riddle haunted the physicists of high-energy theory, the monopole problem. The mathematics of the early universe predicted exotic magnetic relics, born in the furnace of primordial forces, heavy, indestructible particles that should have lingered like fossils of creation. Yet, in all of the heavens, not a single one has ever been found. These were not small inconsistencies. They were cracks in the foundation. Each paradox deepened the mystery. If the universe began in a fiery birth, why did it begin so flawlessly? Why was the infant cosmos already smooth, already balanced, already bereft of the relics it should have carried? The questions forced scientists into a new kind of daring. Perhaps the Big Bang was not the beginning, but the result of something deeper. Perhaps the event that looked like a singular birth was only the visible surface of a hidden process, one that reached beyond the horizon of human imagination. The paradoxes did not undermine the vision of a cosmic birth. Instead, they sharpened it into a deeper mystery. For in these contradictions, the universe seemed to whisper that its origin was stranger, more delicate, and far more profound than anyone had yet conceived. Chapter 5: Inflation and the Seeds of Eternity. In the winter of 1980, a young physicist named Alan Guth sat at his desk, wrestling with the riddles left behind by the Big Bang. The equations refused to rest. The horizon problem, the flatness puzzle, the missing monopoles, each one a thread that threatened to unravel the story of cosmic birth. And then, in a flash of insight, Guth glimpsed a solution so audacious it seemed almost impossible. What if, in the very first fraction of a second, the universe had expanded not slowly, not steadily, but in a violent, exponential surge? This idea would be called cosmic inflation. In less than a trillionth of a second, space itself could have swelled by a factor beyond human comprehension, stretching a subatomic speck into a vast expanse larger than the observable universe today. Inflation rewrote the paradoxes. The horizon problem dissolved. For once tiny regions of space, in close thermal contact, had been torn apart and spread across the sky. Their shared uniformity became the smoothness we still see in the cosmic microwave background. the flatness problem was eased, as the furious expansion ironed out the wrinkles of geometry, leaving a universe that appeared balanced, flat, and finely tuned. The monopole problem too was tamed. Inflation diluted the exotic relics of high-energy physics, scattering them so thinly across the cosmos that none would ever be found within our cosmic horizon. But inflation was not merely a patch for old problems. It carried within it the seeds of creation itself. Tiny quantum fluctuations, ephemeral tremors born from the uncertainty of the subatomic world, were stretched across the fabric of inflating space. What began as microscopic ripples were amplified into vast structures. These ripples became the blueprints of galaxies, the invisible seeds from which stars, clusters, and eventually life itself would grow. From randomness, order, from quantum whispers, the architecture of the heavens. And yet, inflation carried a final revelation, a whisper of infinity itself. In many versions of the theory, inflation does not end everywhere at once. In some regions, it halts, allowing galaxies and stars to form. In others, it continues, unchecked. The result is a cosmos that is self-reproducing, always inflating in some domain, always budding off new universes beyond our view. This vision is called eternal inflation. Here, the Big Bang is no longer a single beginning, but one spark among countless others, each universe born in its own fiery dawn. Together, they form a grander structure, a multiverse, where infinity is not a singular event, but a process without end. In this view, the question of origins shifts. The cosmos may not have begun once. It may be forever beginning. Each horizon hides another. Each creation nested in an endless chain, like mirrors reflecting into eternity. And so the paradox of perfection transforms into something more astonishing still, a universe that did not need to be tuned at all. For in the eternal inflationary sea, every possibility is realized somewhere. Our world exists not because it was inevitable, but because in infinity, nothing is forbidden. Chapter 6, Beyond the Singularity. In the early 1970s, Stephen Hawking and Roger Penrose unveiled the singularity theorems, mathematical revelations showing that under the rules of general relativity, the universe could not have emerged gently from emptiness. Instead, the equations forced space-time to collapse backward, converging inevitably to a point of infinite density and vanishing volume. A singularity, a place where the known laws of physics surrendered their dominion, and logic itself fractured. This was the so-called beginning, a boundary where time itself could no longer be extended further into the past. To many, it seemed a confirmation of the idea of creation, a curtain before which science must bow, admitting its inability to describe what lay behind. Yet the singularity was also a warning. When infinities appear in physics, they often mark not a final truth, but the edge of an incomplete map. If the singularity is not the beginning, what lies beyond it? The universe seemed eternal and unchanging. Quantum mechanics, the other great pillar of 20th century physics, insists that uncertainty reigns at the smallest scales. Energy flickers in and out of existence. Position and momentum blur. Nothing is ever truly empty. When these principles are applied to the universe itself, the rigid singularity begins to soften. The supposed nothing at the origin may not be nothing at all, but a seething quantum foam, a state without classical space or time, yet far from void. Loop quantum cosmology pushes this idea further. By weaving geometry itself into quantized loops, it suggests that space-time cannot shrink indefinitely. Instead, it reaches a smallest possible unit, a minimum grain of existence. As a universe contracts under its own gravity, it does not collapse to nothing. It rebounds, a cosmic bounce. In this view, our Big Bang may have been a big bounce, the expansion of a cosmos born from the collapse of an older one. Time does not end at the singularity. It continues through, like breath inhaled and exhaled, perhaps without beginning and without end. String theory offers another vision. In its mathematics, particles are not points but vibrating strings, resonating across hidden dimensions. These dimensions may extend far beyond the three of space and the one of time familiar to human experience. In this framework, beyond unchanging, the birth of our universe could have been the violent collision of higher dimensional membranes, brains, drifting in a larger arena of reality. What we perceive as a beginning may have been only a spark struck by two infinite surfaces meeting, releasing the fire of creation into our dimensions. And such collisions may not be unique. They could recur endlessly. The universe seemed eternal and unchanging, universes budding off from higher dimensional encounters like droplets cast from colliding waves. Then comes the radical elegance of the no-boundary proposal, crafted by James Hartle and Stephen Hawking. In this vision, the universe has no edge in time, no singular boundary where creation was imposed. Just as the surface of the Earth has no beginning point, it curves smoothly in every direction, so too might time curve, without a sharp origin. Asking what came before the universe, in this view, is like asking what lies north of the North Pole. The question dissolves, not because the answer is hidden, but because the premise never existed. The universe simply is finite yet without a boundary, vast yet without a first instant. Each of these ideas confronts the same riddle. What does it mean for infinity to begin? The singularity theorems suggested that the universe had a starting line, a place where mathematics demanded an absolute zero of time. But as theory deepened, that boundary began to blur. In every alternative bounce, brain, no boundary, the beginning is redefined not as a sharp creation, but as a transformation. The infinite may never have lacked being. It may always have existed, in forms beyond human imagining, changing but never vanishing, birthing new realities from old. Perhaps the most unsettling thought is that infinity may not be behind us, in some unreachable past, but woven into the very structure of now. A cosmos with no ultimate beginning may also have no ultimate ending, just transitions, passages, metamorphoses. Eternity may not stretch in one direction, but billow outward in all. And so, the singularity, once thought to mark the ultimate boundary of science, becomes instead a gateway. Beyond it lies not nothingness, but possibility, not an end to understanding, but a call to search deeper, to expand imagination to the scale of the cosmos itself. The mystery of beginnings does not fade, it grows. Chapter 7: Dark Energy and the Endless Expansion. The year was 1998. Astronomers, peering through telescopes at the faint flicker of ancient supernovae, expected to confirm what had long seemed inevitable, that the universe, born in a fiery eruption, must be slowing down. Gravity, the tireless sculptor, should have been drawing matter back upon itself, gently breaking the great expansion. that began with the Big Bang. But what they saw defied every intuition. The light from distant supernovae appeared dimmer than expected, as if carried farther than the models had allowed. The universe was not slowing. It was racing apart, faster with every passing moment. That revelation cracked the foundations of cosmology. Something unseen, something woven into the very fabric of space-time, was driving galaxies away from one another. A force not of attraction, but of repulsion. It came to be called dark energy, a name less of explanation than of surrender, a placeholder for the unknown. In the wake of this discovery, an idea long discarded resurfaced with uncanny relevance. In 1917, Albert Einstein introduced the cosmological constant, a mathematical term he believed necessary to hold the universe in static balance. When Hubble later revealed that the universe was expanding, Einstein abandoned the constant, calling it his greatest blunder. Yet now, decades after his death, the constant returned, no longer a mistake, but a clue. Perhaps Einstein's ghost term was real, a property of space itself, exerting a quiet but relentless push that grows as the cosmos swells. If this is true, then infinity is not only a memory of beginnings but also a promise of what lies ahead. For in such a universe, the expansion does not fade, it accelerates. Galaxies recede into darkness, one by one, until each stands alone, isolated in an ever-deepening void. The cosmos becomes a stage where the future stretches endlessly, not into collapse, but into perpetual unfolding. Yet the nature of dark energy remains a mystery. Is it truly constant, as Einstein's equations suggest, an immutable density pervading space-time? Or is it something dynamic, a field that shifts and evolves, changing the destiny of all things? To answer this, new tools are being built, great machines of measurement and vision. The Dark Energy Spectroscopic Instrument, DESI, mapping the positions of tens of millions of galaxies, seeks the subtle fingerprints of cosmic acceleration written in the clustering of matter. The Euclid mission, launched by the European Space Agency, casts its gaze across billions of light years, tracing how structure has grown under the competing hands of gravity and dark energy. And the James Webb Space Telescope, with its deep eyes tuned to the infrared, reaches for the first galaxies, where the earliest whispers of expansion might reveal themselves. Together, these instruments form a chorus of inquiry, asking the same haunting question: what is pushing the universe apart? If dark energy proves constant, then the future is clear. The universe will expand without end. Galaxies will drift beyond visibility. Stars will burn their last fuel. Black holes will evaporate into faint radiation. And time itself, stretched thin, will grow cold and silent. Infinity becomes a loneliness written across the void. But if dark energy is not constant, if it shifts or evolves, then other destinies emerge. It could fade, allowing gravity once again to gather the universe into collapse. A great reversal into fire. Or it could grow stronger, tearing galaxies, stars, and even atoms apart in a final acceleration known as the Big Rip. In these possibilities, infinity is not steady, it is restless, rewriting itself as the cosmos moves forward. What makes dark energy so profound is not just its mystery, but its scale. It composes nearly 70% of the universe, yet reveals itself only in how galaxies flee. We cannot touch it, cannot see it, cannot bottle it in a laboratory. It is the quiet ruler of the cosmos, more vast and enduring than all the stars combined. To live in such a universe is to dwell in a paradox surrounded by darkness, yet carried forward by its invisible hand. The cosmos, it seems, is not only expanding in space, but in possibility, and so the story of infinity changes once more. It is not only a past without beginning, but a future without end, not a single horizon, but an ever-shifting sea, swelling beyond comprehension. Perhaps this is the deepest truth. Dark energy offers that infinity is not fixed, not carved into stone, but dynamic, a breath that continues, a pulse that will never stop. And as long as the universe expands, the question lingers, echoing across galaxies: what is the true shape of forever? Chapter 8: The Quantum Roots of Nothing. In the silence between stars, there is an idea that troubles even the most disciplined of minds: the idea of nothing. For centuries, philosophers and theologians imagined an absolute void, a place where neither matter nor thought could reside, a pure abyss beyond being. But modern physics tells a stranger tale. For when the universe is stripped of all its galaxies, all its light, all its matter, what remains is not a hollow absence. Instead, the vacuum reveals itself as restless, alive, and unquiet. This is the paradox of the quantum vacuum, a nothing that cannot stop becoming. The illusion of emptiness, quantum field theory, the mathematical scaffolding of modern physics, describes the cosmos not as a stage built on empty space, but as a fabric woven from fields, each extending infinitely, each capable of excitation. Every particle, every electron, every photon is a ripple on one of these invisible seas. And even when the ripples seem to subside, when the fields are at their lowest possible state, the vacuum refuses to be still. Uncertainty, that defining principle of quantum mechanics, forbids absolute rest. Thus, fleeting sparks of energy shimmer into existence, birthing pairs of virtual particles that appear, annihilate, and vanish before they can be measured. In laboratories on Earth, this ceaseless agitation has left fingerprints. The Casimir effect, measured between two parallel metal plates placed nanometers apart, reveals an attractive force with no classical explanation. It is the quantum vacuum itself pressing inward, restless energy demanding acknowledgement. Here, science meets poetry. The void is not void, but a canvas, already painted by the brushstrokes of possibility, a universe built on fluctuations. If the vacuum can create particles, could it not also create worlds? Some cosmologists suggest that the entire cosmos may have been born from one of these fluctuations, not from a timeless void, but from the fertile ground of quantum uncertainty. In this view, the Big Bang was less a singular beginning than a natural outgrowth, a blossom from the eternal quantum field. Inflation theory, the idea that the early universe underwent a rapid, exponential expansion, ties itself to this restless vacuum, a particular form of energy, known as the inflaton field, is thought to have driven space itself into a frenzy of expansion, stretching quantum irregularities into the seeds of galaxies. Those fluctuations still linger, faint yet detectable, etched into the cosmic microwave background radiation. Each subtle temperature variation recorded by telescopes such as Planck is a whisper from the quantum froth of 13.8 billion years ago. From the murmur of uncertainty, order arose. From the trembling of nothing, the architecture of galaxies was set in motion. false vacuums and fragile realities. But if the quantum vacuum is not experiments on the edge of nothing, to understand this unstable foundation, scientists turn to both the infinitely small and the infinitely vast. At CR, the universe collisions between protons are driven to energies approaching those of the early universe. Each impact is a recreation of primordial conditions, a window into the vacuum's hidden structure. Physicists seek signs of exotic particles, supersymmetric partners, or other phenomena that could reveal whether the vacuum's stability is fundamental or temporary. Beyond Earth, the cosmos itself acts as a laboratory. The cosmic microwave background is scrutinized for subtle signatures of inflationary waves. Gravitational wave detectors like LIGO and VRGO listen for the faint tremors of spacetime itself, hoping to detect the ghostly echoes of inflation. Future missions LISA, a space-based gravitational observatory, and the Euclid spacecraft now mapping dark energy's role in cosmic expansion, may one day illuminate whether the vacuum is fixed or shifting beneath us. Each observation carries a deeper implication. Perhaps the universe is not defined by its beginning, but by the constant metamorphosis of its vacuum state. The eternal canvas to call the quantum vacuum nothing is to misunderstand it. It is not emptiness, but potentiality. It does not rest, it seethes. It does not erase, it creates. Some theorists propose that this restless field is eternal, that universes may bud from it endlessly, each with its own constants, laws, and histories. The multiverse, if it exists, may not need a primordial spark, because the quantum field itself is the timeless background, an infinite ocean from which waves of reality rise and fall without beginning or end. In this vision, nothing never was. What we call emptiness is already the presence of everything. Infinity is not a line stretching backward or forward, but the constant hum of existence, refusing silence, a reflection beyond science. The human mind, shaped by survival and story, seeks edges, a start, an origin, a first cause. But the quantum vacuum resists such simplicity. It whispers of transitions, of fluctuations, of a universe that may be less like a book with a first page and more like a song without a composer, a melody that has always been playing, even before ears could hear it. And so the paradox deepens. If nothing never existed, then being has always been. Infinity was never born, because it never needed to begin. Chapter 9. Infinity's Mirror. The Philosophical Reflection. The human mind was never built to contain infinity, yet here it stands, pressed against its glass, staring into a mirror with no frame. Infinity, a word whispered like a prayer, carried through the centuries, carved into the margins of philosophy and mathematics alike. It is both a promise and a paradox, the endless that must somehow exist, and yet cannot be measured. But how could infinity begin, if nothing was ever missing? This question lingers like an echo, circling the chambers of thought, returning again and again with no resolution. To touch it is to fall into a hall of mirrors, reflections stretching into eternity, each answer revealing another question. And yet, even within this bewildering maze, three great doors seem to open before us. Infinity never began. One door suggests a simple, unsettling truth: infinity never had a beginning. There was no spark, no first moment, no origin. Instead, the universe is eternal, without border, without edge. This is the vision of the steady-state cosmologists of the 20th century, who argued that matter is continuously created as the universe expands, keeping its density eternal and unchanging. Though that model has since fallen from favor, the possibility still whispers beneath the mathematics. Some physicists point toward models of a past eternal universe, spacetimes without a beginning, where the arrow of time stretches infinitely backward. Quantum cosmology, through approaches like loop quantum gravity, imagines a cosmos without singularities, replacing the Big Bang with a Big Bounce. In these models, contraction precedes expansion, and expansion precedes contraction, with no true origin. Time itself is a pendulum, not a straight line. But if infinity never began, then existence itself is the ground of all reality. Nothing was ever born. It always was. And the concept of creation is revealed as a story invented by finite minds, seeking a point to rest their questions upon. Infinity did begin, another door swings open, and it reveals a stranger possibility. Infinity did begin. But how? How can something without end erupt from nothing? Perhaps, say some cosmologists, the very notion of nothing is a fiction. In quantum theory, the vacuum is never truly empty, even in the absence of matter. A restless ocean seethes with fluctuations, particles blinking in and out of existence, carrying the whisper of energy fields that never sleep. If nothing is impossible, then beginnings are inevitable. As the physicist Lawrence Krauss suggested, the laws of physics themselves may require creation. The equations allow universes to bloom from the quantum void, like bubbles in a cosmic sea. From zero, an infinite pattern of possible realities could unfold, cascading outward with unstoppable momentum. This view paints infinity not as eternal, but as an eruption, a birth that was forced because emptiness could not hold. Existence became necessary, inevitable, encoded into the fabric of possibility itself. Infinity both began and did not. The third door is the most elusive. It suggests that infinity both began and did not. Here, the paradox is not within the universe, but within perception. Time, as human beings experience it, may be nothing more than an illusion, a construct of consciousness moving through a static tapestry. Einstein himself remarked that the distinction between past, present, and future is only a stubbornly persistent illusion. In the block universe interpretation of relativity, time does not flow. Instead, all moments, past, present, and future, coexist within a four-dimensional structure. The universe seemed eternal and unchanging. Beginnings and endings are illusions born from a creature who can only move one way through the corridors of the infinite. To a deeper reality, there is no before or after. Infinity does not need to begin or not begin, for it simply is. Quantum physics deepens this mystery. In certain interpretations, like the transactional or many worlds views, causality itself bends into strange shapes. An event can be both the origin and the outcome, cause and effect entangled in a loop that refuses to break. Here, infinity's beginning and its absence are both true, held together, like opposite mirrors facing one another. The philosophical implications. What does this mean for the fragile creature who asks the question? If infinity never began, then free will becomes a pattern written into the eternal, every choice already etched into the endless ledger. If infinity did begin, then humanity may be participants in a story that is unfolding from nothing, co-authors of a reality still writing itself. And if infinity both began and did not, then choice may be real. yet also illusory, woven into a reality where cause and consequence are inseparable. In this light, the meaning of existence itself shimmers like a mirage. Is life a fleeting spark in a universe that always was? Is it a necessary ripple born from the impossibility of nothing? Or is it a dream within a timeless structure, where beginnings are merely shadows cast by the mind? Humanity suspended in infinity, and so, humanity drifts suspended inside infinity. Every step taken, every thought formed, occurs within an architecture that has no walls, no foundation, no ceiling. We are witnesses to eternity, mistaking the endless corridors of being for the passage of time. The stars above are not markers of a beginning or an end, but luminous echoes of an infinite design. The galaxies do not move forward into the future, they rest, eternal, within the great tapestry. The heartbeat of the cosmos does not begin, and it does not end. Infinity is the mirror, and humanity is the reflection. To gaze into it is to see not where the universe started, but where it never needed to. And in that realization lies the quiet, unsettling truth. Perhaps beginnings themselves are illusions, fragments of language and thought, cast upon an ocean that has always been and always will be. Chapter 10, Closing Reflection. The silence before the first word. Silence. Not the silence of an empty room, nor the silence between two spoken words, but a silence older than time itself, the silence before the first word was ever spoken. For centuries, humanity has sought that first sound, that first spark, that first instant when nothing gave way to everything. The Big Bang, the cosmic dawn, the imagined moment when the universe leapt into being. Yet as the questions deepen, the silence grows louder. Perhaps that first moment was never there at all. Perhaps it is not a beginning that we seek, but a horizon that forever recedes, unreachable, untouchable, existing only in the mathematics of longing. The universe without a first note. If infinity was never missing, then the universe is not a story told from its first line. It is a song without a first note, a melody that has always been playing, vibrating through an eternal medium. Every galaxy, every star, every life is but a brief harmony within this ongoing composition. Cosmic background radiation. The afterglow of what we call the Big Bang was once thought to be the signature of the very first fire. Yet even this light carries mystery. At 2.7 Kelvin, it whispers not of nothing, but of something that already existed. A relic, not of an absolute birth, but of a transformation, one verse of a greater song. Modern physics has begun to question the finality of that first instant. In some models of quantum cosmology, the singularity dissolves. The Big Bang is no longer a wall, but a window leading into an earlier universe, or perhaps into countless others. If this is true, the silence before the first word is an illusion. The song had no opening measure. It was always playing. The horizon that cannot be reached still. The human mind craves an origin. It longs for a single frame upon which the tapestry is hung. Yet cosmology reveals that the further one peers into the past, the more the horizon dissolves. The universe does not yield its birth, but instead offers a horizon, a boundary of knowledge that no observation can penetrate. The Planck time, less than a trillionth of a second after the supposed beginning, marks the veil beyond which physics cannot see. Equations collapse, predictability vanishes, and what remains is silence. Not the silence of absence, but the silence of mystery. Beyond that veil may lie nothing, or everything. The answer is suspended forever out of reach, like the horizon line that recedes as one walks toward it. This boundary reveals a profound truth. Perhaps the first moment is not something that exists at all. Perhaps it is a construct of thought, a mirage projected by the linear way the human mind experiences time. Like a traveler lost in a desert, one chases the edge of the oasis, only to find it always one step further. The fabric of infinity, if beginnings dissolve into horizons, what then becomes of life itself? The answer may lie in the threads. Human lives, choices, and memories are not isolated sparks burning briefly against a void. They are strands woven into infinity's endless fabric. Every decision, every heartbeat, is a ripple in a pattern that stretches beyond comprehension. From the orbits of planets to the flicker of neurons, each moment is sewn into a greater whole. In the block universe view of space-time, all moments coexist. The laughter of a child, the collapse of a star, the rise of a civilization, all are eternal, suspended in the four-dimensional structure of reality. From within, life feels like a journey, a passage from past to future. But from outside, the threads are already woven, already complete. The song does not begin and end, it simply plays, and every note, including the ones we call human lives, is forever part of it. The human echo in the infinite. There is something profoundly humbling and profoundly beautiful in this reflection. If existence was never born, then neither was it doomed to die. Infinity enfolds all things, and within its embrace, nothing is ever truly lost. The starlight that left ancient suns millions of years ago still travels through the darkness, still carries the imprint of worlds long gone. The whispers of civilizations past may still be written in radiation, in the faint tremors of space-time. In infinity, memory is never erased. It is woven, indestructible, into the fabric of being. For humanity, this means that even the smallest gesture resonates endlessly. A spoken word, a fleeting kindness, a thought carried across the silence of the mind, each becomes a thread in the pattern. Choices do not vanish, they echo. Memory does not dissolve, it becomes part of the song. The paradox of presence, and so, the closing question emerges. If infinity never began, then what we call existence was never born. It simply is. This revelation does not silence the mystery, but deepens it. For in an eternal universe, the human condition with its yearning, its fears, its fleeting joys, becomes both fragile and eternal. Fragile, because each life is a temporary form, a brief chord in the infinite song. Eternal, because no chord is ever erased, no vibration ever silenced. The paradox lies in presence itself. To be alive is to dwell within time, to feel the current carry one forward. Yet to step back is to see that there is no current, no flow, only the vast stillness of infinity, within which all rivers already rest. The human heart beats within time, but existence itself beats beyond it. The silence that remains at last, the silence returns, not the silence of absence, but the silence of awe. The silence of standing at the threshold of a mystery too vast for words. If the universe is less a story with a beginning than a song without end, then silence itself may be its truest note. Silence before the word, silence between the stars, silence within the mind that dares to ask what infinity truly means. Perhaps the song will never yield its origin. Perhaps the horizon will forever recede. Yet in that endless search lies something precious, the recognition that humanity is part of the melody, inseparable from the fabric, forever a reflection in infinity's mirror. And so the universe does not ask for answers. It asks only for witness, to stand in silence before the first word, knowing that it may never come, and that perhaps it never needed to.